Good morning, everyone. Welcome to yet another edition of Professor Grenfell's Math 12 Statistics class for Riverside City College. Go Tigers. All right, so here we are today for Chapter 3, Data Description. We're going to begin with the concept of center, measurements of center. Basically, this gives us one single estimate for our whole data set. If we describe where it is centered, then everything else is kind of organized around that one central point. So here in this section, we're going to go into various meanings of what do we mean by the center of the data set. It turns out there's different ways to kind of look at it. And the first thing we're going to cover is just this distinction between a statistic versus a parameter. A statistic is a characteristic or attribute that is obtained, a measurement. A characteristic or measure obtained from the data values that are coming from a sample. And a parameter is a characteristic or a calculation, a measure that is obtained from the entire population. Now, keep in mind, most of the time we do not have the capability to go out and take a census. We don't have access to the entire data set for the whole population. So that means most of our calculations are going to be statistics rather than parameters. So we will now discuss page here, the three major methods for determining the center of our data set. So we have the mean, the median, and the mode. We'll also say a few words about this thing called the mid-range, but we'll leave that until the end. Okay, so the mean is defined as sum of all of the values divided by the total number of data values that you have. Or in plain terms, that is the average as we know it. The arithmetic mean is the fancy terminology for what we, regular people call the average. So because there is a difference between the information that we get from a sample versus the computation or the measurement that we get from the population, we do need to make a distinction. The sample mean, remember that is the statistic, and the population mean, so that would be the parameter. These are, essentially similar concepts, similar calculations, almost the exact same calculation, exactly the same. But keep in mind, this is coming from a sample, and this one is coming from the population. So for sample mean, we call this one chi bar. All right, so this is the Greek letter chi, kind of looks like an X. Don't say chi, don't say chai. It's not an energy, kind of T, it is chi. And then, let's see, what do they say? Bar? Well, because there's a little bar over the top of it. So we pronounce that chi bar. And that is, here, the sigma. Okay, so this is a character that we're going to talk about in our support course. This just means addition. So that is the Greek letter sigma. Sometimes when I'm reading the math, the algebra of it, I will pronounce that as the summation. But that just means you add up whatever it is telling you right here, whatever is after that sigma. So that is the capital Greek letter sigma of all of the x, the summation of the x values divided by n. And here, for the population, this one is the Greek letter mu. Okay, So think kitten, not cow. Right? It's not moo, it's mew. Yeah, anyhow. so again, we have the same sort of deal. This is the sum of all of the values, and we're dividing by the total number of the values. So notice here, the distinction is what we call the parameter versus what we call the statistic, right? So we have a different symbol for it. And then we even have a different symbol for the, well, here, this would be the sample size, and this would be the total number in the whole population. So notice we call this one little n and this one big N, because this is smaller and this one is bigger. Okay, so there's chi-bar and mu. But basically, all we do is we just add them all up and divide by the total number. We just take the average. Okay, so population mean or sample mean, whichever, we're going to be computing the average. Let's go to the first example. Let's do a quick example. Example 3-1 on avian flu cases. The number of confirmed flu cases for a 9-year period is shown. Find the mean. All right, so here we have the raw data. Okay, there it all is. So what we're going to do is we're going to take the sum of all of them and then divide by the total number. So we are, so basically the sigma x, right, that portion of it just indicates do 4 plus 46 plus 40 plus 98. See, I'm off already. Plus 115 plus 88 plus 44 plus 73 plus 48 plus 62. Right? This is the way to summarize all of that long-winded business there quickly. This is just saying, here, add them all up. If you want to get into the details of it, yeah, that's what you tell your calculator to do. That's just the scratch work. And then we divide by what? The total number, 9 in this case. So we would divide all of that after we added them all up, all by 9. So this is where we get the 578, all divided by 9. And so, according to the calculator, that is approximately equal to 64.2. It is actually, you know, what the calculator says is 64.22222, so it's 64.2 repeating. But here, all of our data are whole numbers, and so generally our rounding rule of thumb is, you know, what is our data? It has out to the nearest whole number. So whatever calculation we do, we're going to round to 1 extra decimal digit past that. Okay, that's just a general rule of thumb. We'll apply that unless they specify otherwise. And just a casual mention of this, finding the sample mean for grouped data is given by this formula here. And so here we should see example 3-3 as an illustration of what this principle is. Basically, this is just saying, well, we have all of this data. It's already given to us in a grouped frequency distribution. So we're going to take the frequency times the midpoint. So that x subscript m is the midpoint for each one of our classes that we've grouped our data into. And then we're going to divide by the total number there. So essentially what this is doing is it's saying, well, I don't know what the exact data are, but I know that there's, well, you know, just for example, I know that there's 13 data points in between 15.5 and 20.5. So what we'll do is we'll just take the midpoint of that, you know, so that would be what, add them together and divide by 2, so that would be 18, right? We take the midpoint times however many values that we had within that set. That's all that's doing, right? So this is a way of just taking and kind of simplifying the calculation, saying, okay, well, everything within this range, we'll just call, you know, if it's 16 or, you know, whether it's 17.9 or 16 or 19.3, anything like that within this range, we'll call it 18. We'll just count up the total number times 18. Boom, that's the total for that class. We'll move on to the next class and so on and so forth. So see example 3-3. See this one for an example of computing the mean for grouped data. All right, so let's move on. The median is the midpoint of the data. So it is literally the middle value. So in order to find this, we have to sort the data. We have to arrange the data, let's say, in ascending order, going from smallest up to highest, right? From lowest up to highest. If there's an odd number, perfect. There is one value exactly right in the middle. Go find it. That's all you do. It's the middle of the data. That's it. So that's a different way to measure the center of the data set. If it is an even number of data points, well, let's see. We won't have one single solitary number right in the middle, so therefore we'll have the middle two values, and we will just average them together. So essentially here we're taking the mean of the two that are in the center. Okay, so we're going to jump to example 3-5, the number of tornadoes in the United States that have occurred in the United States over an 8-year period is as follows. Find the median. Okay, so here we have the data listed out, 684, 764, and so on and so forth, all right, all of these data. And so the first thing that we're going to have to do is to rearrange it so that they're in order from highest up to lowest. Okay, and that took me a minute, so I paused it while I did that. You notice here as I went through, I combed through the data set and found the lowest value here, 656, so I copied it here. And as I did that, I crossed it out, so that way I didn't double count or skip any, right? If I didn't cross it out, I skipped it. So yeah, now, well, we have 8 data points, so the fourth and the fifth are going to be the middle two. And so here we're going to just simply take the average of 764 and 856. So that is 764 plus 856, all divided by 2, and that gets us 810. So notice here, the median of the data set does not necessarily have to be an item or a number that is from the data set. Okay, now next we have the mode. The mode is the most frequently occurring value in the data set. So to illustrate this, let's turn to example 3-7. So we've got the data here. Okay, so let's see. Let's kind of just keep score. You see which data point or which value occurs the most often. I see a lot of 104s, so let's count those up first. All right, so I have 1, 2, 3, 4, 5 copies of that. All right, so that's pretty frequently occurring. And then what else have we got? I've got a couple 109s, so let's keep track of those. 1, 2, 3, 4, 5 of those. Okay, so 109 occurs 5 times. Oops, not 9 times, 5 times. Anything else occur more than once? If it only occurs once, then don't count it. And if it doesn't occur at all, why are we talking about it? No, there's always that. We got 111. So there were two occurrences of 111, and then 112, 110, 107 didn't occur at all. So which one is the most frequent, 104 or 109? Well, they're tied. There's a two-way tie for first place, and as long as it's an exact tie, there can be multiple modes. It doesn't even just have to be a single mode or 2 modes. There can be multiple modes. In that case, it's called multimodal. This is bimodal that means there's two modes, and the modes are 104 and 109. That's all we got to say, right? And one last little thing, the mid-range is the average of the lowest and the highest values from a data set. So we can say MR, mid-range, that's high plus low, all divided by 2. Just real quick, let's back up to this previous example here. Okay, we kind of already examined the data, and the mid-range is pretty easy to calculate because we've got the lowest value, repeats a bunch of times, but there's no lower value. So we can say it's our lowest. And then there's the highest value. So the mid-range, MR, would be high plus low, all divided by 2. So that would be 112 plus 104, all divided by 2. Gives us 216 over 2, also known as 108. So just a quick example of that. Just a quick overview. The mean, remember we have two different symbols for this, whether it's the sample mean, chi-bar, or the population mean, mu. Just a couple of properties about this. It varies less than the other measures, meaning if we select different samples from within the same population, we compute all three of these different statistics, the variation in terms of the sample means, these will be less widely distributed than the other statistics, the median and the mode. It's used in computing the other statistics used to measure variation, variance, standard deviation, some examples of these. But it can be influenced by outliers. So if we have extremely low or extremely high values, these can shift the mean for the data set to kind of skew it to one direction or the other, either to the high side if we have just a few very, very high values, shift it to the high side, or on the other hand, if we have just a few that are tiny low values, we can shift it to the left as well. Now the median is not as affected by either extremely low or extremely high values. So we use it in open-ended distribution. So let's illustrate that. Okay, now here's the example that I always go to. Most of the time we want to use the mean because it is useful. It is basically a more stable, more reliable way of computing and doing with our data. But there's this aspect that it can be influenced by outliers, and in which case the median would be what we want to look at. So here's the example that I always think about: income. All right. So for most of us here, our incomes are something in this range, and then there's this guy Bezos, right, CEO of Amazon, and and he makes all the money, and then there's us normal people. So according to the mean, even though there's a lot of people in this range, the average income would be something like this. So according to this, we're all multimillionaires as a whole on average. Whereas if you look at the median, which is what you should be looking at, it's the middle value. So it's right in there. And notice that's a more valid measure of the true center of the data set. This one right here, Bezos, right? Throw him away when you're talking about regular average stuff. Leave the outliers out of the picture, or use the median to determine if there are outliers. All right. close it now and pick up with next section 3.2 in the next